All right, we're going to get started. Again, sorry I can't be there in person. I feel really bad about it, but I feel really bad in general right now. And I think the last thing that was needed was for me to give somebody this crappy disease before the final exam period. So, um, all right. Today I'm just going to go through um, any questions that you might have on the final project and what it is that we're looking for. Um, so the first thing you can do, first thing you should probably do is just send me a chat message letting me know that you can see my screen and hear me. Otherwise, I'm just sitting here talking to myself. All right. So we're only going to go for as long as you all have, just questions. So let's get to the first one. Rotten Deep told me that there was a question for clarification about orchestration versus choreography, and like what do they mean? What is the difference between them? And there's a lot of material out there. Um, no, it's on Zoom, it's Lucidchart. But I will go through it just to give you a feel for what the difference is. All right, so let me go make a new. Go down. All right. So the easiest way to think about it is the following, which is if I've got 3 microservices that I want to compose or aggregate, just call this microservice 1, microservice 2, microservice 3. These are just 3 microservices that need to get composed or aggregated. Now, the first thing to remember about this is that when you're composing, when you're putting these things together, you've got to think about 2 forms of composition. So there's 2 perspectives on composition, or 2 facets. The first one is structure or assembly. So this is the composer in this case. And specifically, this is going to be an orchestration example, right? This microservice is going to call that one and get an answer. So it's going to make an API call onto this microservice and get an answer. For that to happen, it has to know the URL that this microservice is listening on. That might change over time. Things come up, things come down, things move. And more fundamentally, this is like, this composer might be reusable, this thing might be reusable. So that's got to get configured. I can't hard code that URL. into that orchestrator's code. And so that brings up one of the patterns that you see me use in my code in a somewhat inconsistent way, but you should be aware of it, is that all of my microservices, when I code them, somehow have a configuration, somehow have configuration information. There's a lot of places you can put this information. But the way that I do this is that all of my microservices have a class, use case, state, sequence. All of my microservices have a class called the service factory. And that service factory that's code. You can weave that in as part of the build. That code will read this configuration file, and it basically calls all. So these also have service factories, because this one might have to access a database, and it needs to know the URL of the database, the password, etc. And so there's always a service factory that knows where to get this configuration information, and it passes config information into like all of the microservices to set them up. It's a simple form of dependency injection. But structure is how does this overall structure find? And that's done by various forms. And there tend to be a bunch of places to do this with the structural information. Environment variables are what 12-factor applications recommend. Sometimes you do it with a .env file that you make sure that you don't replicate into the code repository. That's kind of risky. And then there are also things like a secrets vault. So there's an API to secrets vaults that you can call. But I abstract all of that out into a service factory and a config class. That's structure. And we'll just set that one aside right now and not worry about it. But that's what those service factories are doing. What orchestration does is it has code in it of some form that knows how to call each of these things to accomplish the task. And so orchestration is the request comes in, it tells each service what to do. Now this can happen synchronously. I call this one and get an answer. I call this one and get an answer. I call that one and get an answer, or it can happen asynchronously. But the critical thing here is that there's linear code or code with a kind of control flow in it, which is, do M1, do M2, do M3. If, M1 failed, undo, like it'll call another method to get rid of it. So there's logic in here on how to do that. It's code. I mean, that's the default way we would all do it when we wrote the code. So that's orchestration. Choreography is different. Choreography is all event based. It's all event based. So the first thing is this is behavior. It's going to be behavior. So when you write one of these things, a method, a function in one of these things, and you're doing orchestration, it's the standard way that you think about it, which is you write a function, you know, def f, you do a bunch of stuff, you may call something, bunch of if statements, right? And then at some point, since it's a function, you return the answer. Right? So you're called by something. You process it, you may call other things, and you return. That's the standard way we all learn to program. The way to think about events, now this is not strictly what to do it, but it's the simplest way to think about it is, right, so I've got right, all of these things. Not the way to think about it. The way to think about this is the following, is that there's logically one function in the microservice. There's logically one function. And this one would have parameters. And here, there's logically one function. And what that only parameter in there is some kind of event E. And then why does it not want to get rid of that? All that's really in here in all of this code is stuff of the form if E dot code, like what's the event code? What type of event was it? XXX. Then basically go call the handler for that event. And so all that's really happening is the events are coming in. This thing does not really want to handle text particularly well. It's just a bunch of this stuff. And these really don't return anything. Because what happens is in the handler, this is where you do some code. You write some code. You can call things here. These may be internal things, but in general, if you're calling another microservice, you don't do that and you don't really return. So let's assume that this event handler isn't really calling another service. It's going to do some computations. And then it's going to basically go and say, emit a new event, right? And the code is equal to xxx done. And, you know, the message is some kind of data structure. It doesn't really return. It just says, I did what I was asked to do. I'm just telling everyone that I did what I was asked to do. And so you have to think about your programming in a completely different way, like a completely different way, which is there are going to be discrete things that happen. And then they emit an event about whether or not they succeeded, right? And so the way that this typically would happen is that, right, this one up here would understand, let's assume that this is a create for something that's a composite. It's going to react to the handler is going to be the composite create, and it's going to have an event with data in it. What it's initially going to do, let's just call it create request. Request, so somebody created the request. All it's going to do is emit an event with the code create whatever this is, M1 request, and then whatever of the data is needed for M1. And then it's going to do that for the other ones. Be one way to do it. Going to just emit an event for each of these. Because it knows it's a composite, but it doesn't know how that composite like gets done. It doesn't know what to call. It has no idea what's happening. It just says, okay, to create the composite, I've got to go say that this implies a request to create this thing, right? And then it's going to have a bunch of handlers of the form def handle M1 created. And it's going to take an event and then do what it needs to do when that's been done. And one of the things it's obviously going to do is that it's not when it's got a successful, each one of these has been successfully executed. when each one of these has been successfully executed, it's going to be something like if M1 succeeded and M2 succeeded, well, the two other parts have succeeded and M3 succeeded would be emit, E where the code is, C created. So it's a completely different way of thinking about how to write your methods, how to write your methods in a microservice is you don't think about it says, okay, I'm listening for something to happen. I do something and that may cause me to emit other events. But there's no like single point of control. There's no single locus of control. It's a completely different way of doing it. So you don't have to get like super. No, there's another kind of way to think about when you're doing it orchestration based is you can actually also think about a state machine. And so whenever I'm in the process of creating something, so let's assume that I get a create event and it's got an ID, right? Well, there is a logically a table. So it does have tables. So where'd the tables go? It logically has a table for each identified thing. So I'm making, I don't know, a travel itinerary or something. It's what's the received event? So what's the received event? What's the current state of the thing? And then what's the code I run in that state? And then what event do I emit? That's kind of another way to think about it. I don't need that thing to be that wide. What's the other event I emit? So technically, this is a state machine. So you can think about it doing it this way. This could be kind of incredibly complicated, but it's a completely different way of thinking about putting microservices together. So the call return one, we're all comfortable with. The call return one, we're all comfortable with. We all kind of have our head around that. But what happens with the choreography is that these lines don't exist in any meaningful sense. What actually happens is that there is a thing, a broker that's there. and it's got a set of topics. And so those were those things we were doing, like, request topics. Okay, so it does not want to let me do these things. So let's go back over here. It does not like text, apparently. All right, so topics. Right. And so it's request, create, XXX. XXX. These are just, and so what happens is this microservice subscribes to these topics. It knows what topics to subscribe to. How does it know what topics to subscribe to? That's structural composition. That's structural compositions. Where'd my structural composition go? Anyway, I don't know where my structural composition, but that's what it gets in the service factory. Is it just knows? All right, so I lost where'd my topics go? All right, so all right, so it basically just knows the service factory. The code is written to logical names for topics to emit an event to and subscribe to. The service factory actually sets them to the actual values based on the configuration information. But this just subscribes to events and gets triggered when an event occurs and emits events. And that's how this thing works. Now, easiest way to do this is this get a little weird, right, sometimes. And it's also pretty common to like getting a microservices connected to one of these things can be a little tricky. And so what I actually do in practice is that instead of the microservice subscribing, right, there's a little function as a service, because these things function as a service works really, really well. That's what subscribes. That's what gets triggered. And then that just basically calls that. You could think about these functions as a service, these little individual functions as a service, as being a way to do those if then else. Is instead of having a bunch of these things based on the event, I write a bunch of functions as a service, and then it knows what function on which of these workers to call. The net of it is that nobody calls anybody, nobody returns to anybody. They get an event, they react to it, and then they emit an event. And that's how the microservices get coupled together. Now, any of this kind of coding, even in the synchronous case, can get really complicated because you're calling A and then B and then C failed. So I've got to undo A or B. You've got to remember like the state of all these things. That can get kind of complicated. So you can do it in code if you want, but you will see over time that the code gets really, really freaky. And so there are higher layer abstractions that you can use to program these things. And so all these cloud providers have a higher layer abstraction way of doing it. That's some form of workflow. On AWS, that's called a step function. And on Google Cloud, it's called a Google workflow. And so we've covered on the composite, we've covered the thought of I'm going to orchestrate synchronously, I'm going to orchestrate asynchronously, right? I want one that method one implementation that just does receive and emit events, and then another one that uses some higher layer piece of code like a step function or Google workflow to do the orchestration. The latter two, you can just keep it really simple. I'm not looking for sophisticated application logic. I'm just looking to see that you at least tried to do the concept and you've been doing some thinking about it, because it's a radically different way of thinking about how to write code. And in large systems, it's actually the most common way to do it. So as you start, because everything in the cloud is asynchronous. So as soon as you actually start getting into doing anything at scale, whether it's number of microservices, number of requests, amount of data, you've got to completely change the way you think about writing code. And that's a huge mental shift. And that's also a style of programming. Event-driven processing existed for like 30 years. The completely different way of thinking about it, but it's a way that is critical. So I just want you to get some experience and visibility doing this, which is why I'm asking you to like at least do it, show that you knew how to do something like this with topics and functions, etc. That's all that I'm looking for the choreography. And then for the orchestration with workflow or step functions, again, it's a much different way of thinking about doing things, because you're thinking about this visual process, little code snippets and stuff. So it's effectively very synchronous like, but it's programmed in a higher layer abstraction. And when you get one of these orchestrations that is orchestrating lots of things which could fail, happen asynchronously, the synchronous code is a nightmare, because you've got to handle like all these conditions of what could have happened and couldn't happen. And so there's just a simpler way to do it with a higher layer implementation. And so that's all I'm looking for the step function. So just something really basic and simple. But you've got to do those two in addition to the two that you've done in the composition. So that's kind of the explanation of what I'm looking for choreography and orchestration. So are there any, I mean, that's about the best explanation I can give. There are examples out there. I mean, basically, I can try and find some, but you'll wind up doing exactly what I do, which is I just go look for a GitHub project that's kind of an example that's kind of right or kind of what I want to do, and then I go fix it. And so there's lots of them out there, but those are the two approaches: event-based orchestration or call-based choreography. And I'm just looking to see that you've used a workflow engine for call-based choreography and that you've demonstrated the ability to do basic event-driven processing. That's what I'm looking for on that. And it's not the depth or the completeness of having done it. It's just the fact that you got something to work and you got a feel for what it's like. So that's what's going on there. Let's go back and share this again. All right. We'll go back into Ed. So I answered that question. All right. For the security requirement, does username and password with JWT account as an equivalent of Google login? This question has been asked at least 3 or 4 times already. And the answer to that is no, it does not. You've got to use a third-party OpenID provider. So Google, Facebook, GitHub, whatever. You've got to use a third party OIDC. You cannot be your own IDC. And in a previous lecture or office hours, I can't remember when, I went through and explained why, like what's the purpose of asking you to do this. So it's been covered in a lecture somewhere. For the requirement function as a service reacting to an event, does that mean a Lambda or Cloud Function needs to be called via a database trigger or in response to a message sent to a queue? Is it sufficient just to call the fast from? No, it is not. It's not enough to just, well, all right. So again, I mean, if you were a lawyer, um, the way that function as a service works is that it turns an API call into an event. So strictly speaking, the answer to that is yeah, that would, but that's not what we're looking for. Easiest thing to do is just have one of your microservices emit an event, write a function that reacts to that event, and then have that function put something in a database or send an email or whatever. So I would say the easiest thing to do is to just have one of your microservices emit a function on a topic, have another function on a topic that just logs it or does something. And that's something that's clean and simple and real quick and would satisfy the requirement. All right. So I've gone through the overall requirements a few times. API gateway with basic routing and authorization header. Are there any questions on this? All right. So I know we mentioned last time the requirement does not have to be implemented for all services. With that being said, can we only implement API gateway for one service? We are using Google API Gateway, which only supports API addresses with a domain name, meaning that I cannot directly connect to the services hosted on a VM or in a container on a VM without purchasing a domain name. Okay, I don't understand how that would even work for one service if you need a domain name. Because how is it implement API gateway for one service? Well, I mean, part of the way that you do that, okay, so I don't understand this question. So, Yuang Fan, can you try to explain this more clearly, please?
Yeah, so in the Google API gateway configuration, we have to
Yeah.
specify like what the address of the service we want to connect to. And
Well, right, how would you do anything in the API gateway without having an address for a service?
yeah, but the thing is we cannot just supply an IP address. Like we need a domain name. I tried an IP address and it says it doesn't allow like
No,
IP.
I mean, if you've got a VM, like if you've got an EC2 instance, it's got a domain name.
Uh, oh, does EC2 have one? Because I've tried it with the Google Compute Engine VMs, and it only has.
Okay, the Google Compute Engine one also has a domain name.
I can only find an external IP address. I can't find
Well,
a domain name.
yeah, but there must also be a domain, must be a URL for that that's got a domain in it.
Uh, I can look into that, but I didn't find one for now.
Google Compute Engine, public. All right, so I'd have to take a look at this. This seems a little strange to me. Um, I've never seen anything that created a DNS name, IP address. Well, also but the VPC should be able, the gateway should be able to access a DNS entry because the API gateway is in the VPC.
Yes, but
The domain is just, I mean, you literally cannot have a service without it being in some kind of domain. It's not a meaningful thing.
uh, um,
Yeah, they all have a private DNS name within the VPC, and the API gateways in the VPC too.
all right, I see. Yeah, I'll try to find.
If you can't figure that out, let me know. But
Okay.
all right. I mean, I've done it, but I'm getting old and I don't remember how I did it. If I have to go back and figure out again how I did it, but in essence, what you're basically what basically you're confusing is a custom DNS name versus one that's automatically generated. If it's a custom DNS name, then yes, you have to go get your domain. But if it's just the default one that's generated, the API gateway should be able to communicate with it because API gateway has got to be able to route to all kinds of things that don't have a public DNS name. Matter of fact, the vast majority of targets of an API gateway are not going to have a public DNS name.
Mm-hmm.
All right. All right. So, Google login equivalent, issue JWT token with grants, validate token in middleware. Right, any questions about that one? I did go through it in a lecture, but are there any questions about that one? All right. Observability. Um, you don't have to do it for all your microservices, but at least for a couple of them, you should use middleware that emits an event. And if it calls another microservice, it propagates a correlation ID in a header to the target microservice. Demonstrate in a cloud's logging tools kind of almost happens for free because any microservice you deliver, it tends to have the option of having standard out and standard error routed to, so it's CloudWatch in AWS and it's the Google logging on Google. And all you've got to really do is then just demonstrate. You can even just take a screenshot of the fact that you actually went in the CloudWatch or the log console and you can see the events. So that one's pretty straightforward. The questions on that one? Basic atomic microservices, gone through that a few times. REST API, so open API document for all microservices. The world will not come to an end if you only do it for two or three of them and don't do it for all of them. I'm not going to have a cardiac arrest. As long as you do it for a couple, it's fine. I've talked about the best practices that I tend to follow for an open API endpoint. There's also lots of documents out there. Google makes recommendations about REST APIs. Um, there's articles like RESTful API that makes a recommendation. You just have to specify the pattern you picked and show how you applied it. HadioAS is the links section. You only have to do that in a few cases. You don't have to do links for everything, but at least demonstrate that you understood how to correctly generate, responses that had both data and then the links to the related things. Pagination, that's limit and offset. You only really need to do that for one microservice. And then for post 201 created in a link header, this is for the case where you don't know the ID for a resource in a collection until it's created. So for instance, assume your microservice were just inserting a record in an auto increment table. You don't know the primary key until the inserts happened. Right. And so there's no way that the calling service can pass an ID in. You've just got to demonstrate a mechanism by saying, okay, what's going to happen is I'm going to do the create, and then I'm going to return a URL saying this is where to find it. And then at least one path must implement an asynchronous execution pattern, i.e. basically accepted with a URL to go to get that they can pull to get the answer. Composite service we went through. That was what I went through at the beginning of the lecture. At least one external cloud service. I've shown examples of calling Smarty Streets and a couple of other ones. I'm not super hung up on which service that you use. It can be something simple, but just demonstrate that you have the ability to call it. Right. Setting up a disk, so end user notification. I mean, basically the easiest way to do this is to just have a topic user created. And so whenever a user registers, you just emit the user created event, and then you've got a function as a service that reacts to that event and sends an email. It's like really straightforward. You could set up a Discord server like I did in the example and send a message to the Discord server. I just showed how to do that because it was cool. But the easiest thing is by far just sending an email. GitHub, you have to have a repository for each microservice. You're going to have to give us links to it and give us permission to go take a look at it in case we want to take a look at it when we're doing the details of the grading. You should have a project, a GitHub project that links your repositories together, and then just basically demonstrate the fact that you have taken some issues on the individual repositories and you can show them in a Kanban board or the overall project. One example of GitHub Actions, deploying a microservice on commit. There are sample projects that you can use for that. So whenever I have to do this, I just go say, okay, I go just make a copy of the sample project and then just go put my code in the overall thing and set up the configuration. UI, UX, at least some of your user interface must be delivered to the browser from a blob store. It can't all be in the web applications. Doesn't need to be all of the user interface, but it's just got to be some of it, right? CQRS, I'm going to make this one even simpler. Just build a GraphQL endpoint and demonstrate you implemented the world's simplest GraphQL service and can answer it. It doesn't need to have all the data. Just keep it real simple so that you've had at least one pass through GraphQL. And again, the easiest way to do this is to just find a GraphQL sample project and tinker with it a little bit. So those are the technical requirements that we're looking for, right? And then there has to be a demo of the recording in addition to the live section. That's typically going to cover more material than the 15-minute review with the TA, and then a presentation and a document. And there's a link to the template. All right, so I may have to go and refresh this up, but it should look something like this. We're not super hung up on the form of this. All right. But there's got to be something that describes the things that you've done, why you've done them, how you did them, etc. And that's just to help us understand the demo. And so that's what we're looking for in the documentation. And so I answered the 2 questions here, and there were no additional questions here. So are there any other questions that we should cover right now? All right. I believe the TAs are going to continue to hold office hours during reading week. And I'm on another business trip, but I will also have office hours and recitations. My schedule's somewhat hectic, but I will try and let you know as far enough in advance. If you have a specific question, you can post it here or on the mega thread, and one of us will jump in and try and fix and resolve it. But again, this is concepts, understanding it, because it's cloud applications are vastly different than the way that you've learned to program and build things up until now. I mean, it's a completely different way, microservices, events, calling things, just completely different. All I'm really looking for is, did you just take a broad pass through all of the core concepts and capabilities? It's not the depth or the details of the correctness. It's just, did you give it the old college try? Did you take a shot at it? That's all we're looking for here, is that you've had the basic exposure and understand it, and that you figured out how to work together as a team. So that's what we're looking for. We're really lenient. The grading is very simple and generous. Your quick question about PaaS. If we wanted to just convert our entire system to deploy it on Elastic Beanstalk, would that be allowed, or do we have to have at least a couple services nominally? You have to have one service on a PaaS, one on a VM, one on a container on a VM, and then the other one can be wherever you want it to be. I have a feeling that if you decided to just do it all on Elastic Beanstalk, you would not be shot. So at this point, I'd prefer that you did the instructions that I laid out. If you haven't done that, we're not going to have a stroke. We won't take off points, okay? Because there's a lot of concepts here, a lot of moving parts, and my goal is to just get you done and get you out of here for the end of the semester. So we're not going to be super hung up on that. Haha, okay, thanks. So anyway, that's the answer on that. Other questions? They're going to come up as you're going through it. So please do not hesitate to reach out. Now, those of you who've been in my database class, we can wrap up early then, and you can go write code. If you post additional questions on the mega thread and you explicitly ask for an example or more detail, like I'll try and go create an example when I'm bored in a meeting or when I don't want to listen to my girlfriend talk anymore. So I can try and be more precise, but I just don't want to start writing, because if I go do examples for everything, I'm basically doing your project for you. But if you're really stuck or buffaloed and you need something that's more specific and concrete, post and I'll see what we can do. I can either find an example online, because I don't know more than you and I'm not smarter than you. I'm just apparently much better at Google. Probably because I know how to ask the questions. But if you get stuck and you need something more specific, let me know and I'll try and pull something together. Been a rough semester for all of us. I've been sick a lot, um, which has been it's been kind of grinding me down. So I have not been around or as available. And my work life's been crazy, much crazier than normal. So I mean, I kind of wish I had done a better job this semester, but on the other hand, there is a lot of useful, good stuff that you did here. And I do write recommendations for people who take this course. And I do have references. So if you ever in the future have to ask me to write a letter of recommendation for you, you can just resend me the link to your project. And then I can start factoring that into the letter of recommendation. So it's kind of helpful because I got something specific that I can talk about, a specific project that I can talk about in your letter of recommendation. It's the nature of the university experience that it tends to focus solely on negative feedback. The professor sits up at the front of the room and talks to you and tells you things and then tells you to read things. And then a few times a semester, the professor asks you questions, you answer them, and then the professor tells you what you got wrong. If you think about it, that's the way homework and exams work. It's inherently a negative feedback experience, which is really not good because you don't get enough to do positive feedback. And uh, I don't need to teach, and it takes up a lot of time, and things have been crazy. Um, but you do not ever doubt that you individually and collectively are extraordinarily talented, innovative young professionals. I mean, I am literally in awe of you much of the time. I probably don't show it enough, but you really are an extremely impressive group of young professionals. And a lot of the other professors feel the same way. You are the best and the brightest of your generation. And we don't say that enough. We come back, we give you bad grades. But the fact of the matter is, you're the best and the brightest of your generation. You've got tremendous promise. You're going to do great things. Right? Just be confident, move forward, do the best you can. And we're looking for reasons to give good grades in this class. I know that we live in a grade obsessed world, but we're looking for reasons to give a good grade, not to give a bad grade. So listen, I'll be around. The TAs will be around. We'll help you get over this hump. Um, I've covered everything, that I wanted to cover during the semester. There's a ton of detail and it was a lot to absorb, so I could try to point you to things to help you clarify it. But listen, be confident. This is going to go well. It's going to be fine with respect to this course. I hope to stay in touch because I stay in touch with a lot of the students I've, taught, especially in this course. And if you need recommendations or something in the future, don't hesitate to reach out. But you really should be very proud. And it's been a pleasure to be your professor. So I didn't have anything else I want to cover right now. Are there any last minute questions? Otherwise, we can just wrap up and this will just start turning into asynchronous office hours over the next few days. But are there any questions? All right. Thanks a lot and have a good weekend.